Hello everyone. Today we want to work with two robots at the same time because we are like 10 people in the group and there's like two robots. I want you to get familiar with the teach pendants of the Mitsubishi robot and ABB robot. So I made this simple pick and place like task so that you should basically you don't have the uh, computer to write the code on. You should write this code exactly the way it is using the teach pendants on the robot controller and run it. So this should be like this. This is on ABB Rapid. You can see how it will work. You can see which ones are move J, which ones are move L linear, how the speeds should be controlled. When it's moving linearly, it's moving slower. When it's moving with joint movement, it's moving faster. So this is the movement that you can see. Move J is coming here, linearly goes down, grabs the cube, linearly goes up slower, and then this is move J. You can see they are curved. These are move J's. Only here up and down will be move L, and here up and down. Let's take a look at the rapid code for it. I think here. This is the code. I have only 3 points. One is P1, picking place, P2, and P home. And I made the code in a way that it's like this is the rapid code, but here as a comment in front of this, I have written the equivalent Mitsubishi code. So if you write this code in the Mitsubishi, it will do exactly the same task. So you can do the same, you can see the similarity. Move J offset that was written here like this. In Mitsubishi, you should write it like that. And like only thing is that the set gripper close and set gripper open will not work in the real robot because the signals are not defined. So you just put here wait time. Wait time 1 second, and you should do this task basically in the air, not picking anything actually, but you do the exact movement. You try to make this movement that is exactly like this one. There's a home position, comes to the approach position, the offset position of the P1. P1 is here. And then linearly goes to the P1, uh, grabs it, waits here like 1 second, moves up linearly back to the approach position, departure position, now we say, then moves with joint movement to the uh, approach position of the P2, linearly goes down to the P2, and then linearly goes up, and then returns to the home position. So yeah, this is basically entire code, and I made it actually here. Let's see how it works one more time, and then the simulation. Basically, let me reset the simulation. Mhm. Linearly down, grabs it, picks it up, joint movement. You can see it's a curve, linearly down, linearly up, and then goes back. The code you saw there, I made this also comparison. Move Ls are here when it's going from approach position down, and from the like the where it's gripping, from there it wants to lift up, it's move L, and again where it wants to place the cube, it goes with the move L down to the position from approach, and then goes to the departure again linearly up, and then move J home. And in only thing in the Mitsubishi robots, you can see that the speed is given on top of the program. And you can repeat this if you want to have different speed. For example, here after this part, you can put speedy here 20 millimeter. You can put here speedy like 50 millimeter. So you can everywhere that you want to have different speed, you have to use this command in these places. Try this on the real robots, modify the programs. Mostly you should work with the teach pendants. So I hope during next 2 weeks you will make your time to work with them, and after that we will do actual tasks with them. Okay.